Hello and welcome back to our review on Honors Algebra 2, Progress Check 1. We're working with Unit 1, Topic 2, and so I'm working with Formative Assessment number 1. So it says graph both functions on the coordinate grids below. So we're working with our cube root functions, and we also are given the value that is, in a sense, going to be negative. So just some kind of information when we're dealing with transformations and other things like that. So we're really saying we have a negative a value, so that means that it's going to be a reflect over the x-axis. And right here, when we have that, in a sense, that x minus 3, that means that we're going to be moving it right 3 units. So how to actually kind of approach this, what I'm going to do is actually I'm going to graph our cube root function, and then what I'm going to do after that is I'm going to apply those reflections, or I'm going to apply those transformations as relating to the original parent function. So I'm going to do the original parent function in red, and then I'm going to move on to the actual function, and so I'm going to do that in blue. So I'm going to start off with 0, 0. So we actually have 0, 0, we have 1, 1, and we have negative 1, 1. So there are more points that are actually applied to this, but what ends up happening here is that once we kind of move out from there, if we do, like, let's say the cube root of 2, that doesn't work. Cube root of 3, cube root of 4, cube root of 5, cube root of 6, cube root of 7, cube root of 8. This actually finally becomes 2, and then same thing on the opposite side over here. So that becomes negative 2. So we end up getting a graph that looks something like this. So that's our normal parent function. Not the most perfect job, but you can get the idea. So now what I'm going to do here is I'm going to do its reflection and then moving those units over 3 units. So when I reflect it, that means that this point right here, that just keeps getting in the way. So this specific point, like let's say 1, 1, goes down to negative 1, negative 1. And then I move that over 3 units. So I flip that. So, and then 1, 2, 3, make my new point. Flip that over, right? So it's now down here, 1, 2, 3. And now that's going to be right here. Since this point at 0, 0 doesn't really move anywhere, all I just really need to do is move it 3 places, so that's going to be right there. And then actually what you can do here is once I start to have kind of a guide for my points, then I can kind of fill in the same pattern that this was going. So notice how that was kind of going at a diagonal. And then right here, I'm going to flip it over and then go 1, 2, 3. And so that point would be right there. So we end up getting this type of graph. So it's going to look something like this, just like that. So that will be our transformation graph. Okay, moving on to here, there's actually a couple things I need to do before I actually start to figure out my values, especially when I'm dealing with the transformations. So we don't need to worry about a reflection kind of like we did before over the x-axis, but we do have some other things. So whenever we have a value that is in front of an x, we actually need to factor that out. So we're actually going to factor out a 1, and we're going to write this as x, and then also it actually is going to apply with that plus 3. So if we do negative 1 times x, that gives us negative x, but negative 1 times something gives me 3, and that's actually going to be minus 3. Okay, so this negative 1 is actually going to be applying as my b, the minus 3 is going to be applying as my c, and then the minus 6 is going to be applying as my d. So there's a lot of things going on here, and I don't have very much room to actually do this. So for this, I'm going to say my b value is going to be equal to negative 1. So that's going to be kind of important. That whole like x minus c business, the x minus 3, this is going to be moving to the right 3 units. So 3 units. And then this minus 6 is going to be moving down 6. So that's going to be down 6. Okay, so what does the negative 1 for the b value do? Well, this actually does another reflection, but instead of reflecting over the x-axis, it reflects over the y-axis. So axis. So our normal parent function, I'll do it pretty much the same way that I did with the other one. So that's going to be 0, 0, 1, 1, 4, 2, and then 9, 3. So there's my function right here. So my normal parent function. So whenever I'm dealing with transformations, I need to think about what I'm actually going to do first. I want to apply the reflections or any type of vertical stretching or dilation that's being applied to the graph first and then moving them. So if I end up reflecting them, that means that all these points right here, they end up going over here. So that's going to be 4 and then -9. So I'm going to take each one of those points. I'm going to most likely probably erase these as I kind of go through. Notice how the origin really doesn't change as well. And I'm going to move them right 3 units and then down 6. So I'm going to start off with the origin. So I'm going to go 1, 2, 3. I'll do it in blue. So 1, 2, 3, and then down 6. 1, 2, 3, 4, 5, 6. So mark my point right here. And then still kind of set it up in that same fashion. Point's going to go here. And actually, if you think about how this is over 4 units and then up 2, I can do the same thing from this point. 1, 2, 3, 4, and up 2. 1, 2. And then this was over 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then up 3. 1, 2, 3. And then this is my parent function, or this is my transformation function. So this is the one that I want. Okay, so describe the characteristics for each one of these. So that sounds pretty good. So so for the first one, the point of symmetry, or known as the point of symmetry is actually going to end up being, for F, is going to be 3, 0. While G, on the other hand, is going to end up becoming -3, -6, or excuse me, 3, -6. So they were both moved over 3 units, but we didn't really need to worry about that the other one was moved down 6 units. The endpoint, by the way, is referred to when does the graph actually stop, whether it starts at that point or whether it stops at that point. The domain is going to be all real numbers for this specific one. Right here, this is going to be from -infinity all the way till I get to the x value, which is going to be 3. And since it is actually at 3, we do include 3. The range for F is going to be all real numbers because it goes from -infinity to +infinity. The range here, since it goes from 6 and then keeps going above, so that's going to go from -6, I should say. -6, including it, and then all the way to infinity. Intervals of increasing. So in this case, this graph looking from left to right, it is not increasing at all. So we would say never or none. And then over here, neither is this one if I'm looking left to right. So this is never as well. And then decreasing intervals, in this one, it is actually always decreasing as I look at it from left to right. So this is going to be from -infinity to +infinity. You can also say all real numbers, any version of those types of things. And then over here, it is -infinity all the way until I get to the value 3. So it is -infinity until I get to 3. Now, depending on who your teacher is going to be, they'll either say that they're going to include 3 or not include 3. So what I'm going to do here is actually I'm going to include 3 because that is more of the definition of when I say something is increasing or decreasing on the interval. It does include that actual value. So it says determine the average rate of change for each function on the interval from 0 to 3. So what I'm going to do here is I'm going to take this interval 0 and 3 and figure out those specific values. So I'm going to take f of 0, and so I'm going to say negative cube root of 0 minus 3, which actually ends up giving me negative cube root of -3. Now that seems kind of odd, but if I actually take a look at where my 0 is for my first function, it looks like that it is actually going to be somewhat kind of right around there. So you'll notice that it's actually positive. So that's kind of weird because I have a negative. But really what happens here is actually I can take out a negative because I could rewrite this as negative cube root of -1 times 3. And so that I could actually say negative cube root of -1 times cube root of 3. So, and then we can say that that's actually going to take out and the negative is actually going to go away. So I'll just rewrite it back to the cube root of 3 is going to be my actual value. So that's going to be my order pair. So that's going to be 0, comma, cube root of 3. Now I'm going to figure out what f of 3 is. So it's going to be negative cube root of 3 minus 3, which is in a sense going to give me negative cube root of 0, and so that's actually going to give us 0. And we can see right here, right, we have that actual order pair. So to figure out the average rate of change, what we do is we do f of b minus f of a over b minus a. So in this case, we're going to let, in a sense, a be 0, b be 3. So I'm going to say f of b, which is actually going to be 0 minus, and in this case, this is going to be cube root of 3 over b minus a. So b in this case was 3 over 0. So we're going to get the value negative cube root of 3 over 3. And we can actually just keep it in that form, right? We don't even need to simplify it any further. So that is going to be the average rate of change, also known as slope. Okay, if I do that for the square root function, so this is going to be, I'm going to write this again. So g of x equals square root of negative x plus 3, and then I think it was minus 6. Okay, so I'm going to place in g of 0. So it's going to give me square root of negative 0 plus 3, and then minus 6. So this value is actually going to be square root of 3 minus 6, and just keep it like that. You don't need to actually do anything further. I know this is going to get kind of confusing, but really I can't simplify that any further, so I'll just leave it as is. Then I'm going to do g of 3. So that's going to be square root of negative 3 plus 3 minus 6. And we can see here that those two cancel, and I'm actually left with square root of 0 minus 6, which is going to give me negative 6. Now, as I'm setting up that slope problem as before, f of b, which is going to be negative 6 minus, and then I'm going to say square root of 3 minus 6, but that has to be in a parenthesis. Okay, over 3 minus 0. So you'll notice the bottom just ends up becoming 0 because we're still doing 3 minus 0. Now, if you notice right here, we have this negative right here, and which means I need to distribute to everything that's on the inside. So really what we're saying here is negative 6 minus square root of 3, and then plus 6. And the reason why it's 6 because it was originally negative 6, and when we do a minus minus, that's going to give me a plus. You'll notice that the negative 6 and the positive 6 cancel, so I'm actually left with negative square root of 3 over 3 is my average rate of change for the g of x function from, in a sense, what our interval was from 1 to 3. Okay, so it says draw a line to match each graph on the left with its inverse. So the thing that I use to try to figure out what my inverse is I look at where the vertex is located. So the vertex is located right here at 0, negative 5. So then I know its inverse is going to be, in a sense, negative 5, 0. And then I also notice that it's opening up to, in a sense, it's going to the positive y value. So the inverse is actually going to its opposite letter. So that's going to be going to the opposite letter, mean the x. Okay, so where do we have negative 5 comma 0? So that would be located, let's say, right there. So that is going to be this value, c. So c will match up with number 4. Over here, I notice that this point here is going to be negative 5, right? So there is no difference here, right? Because if I end up flipping it, so which means that its inverse is actually also going to be like this, but instead of heading up yet again to the y direction, it's going to be heading up to the x direction in this fashion. So it's going to look something like this. And hey, that is actually what a is going to be. And the last one, this is going to be at the point negative 5 comma 0. So that means that the inverse is actually going to be at 0, negative 5. Yet again, it's opening up to the y. So in this case, it's going to be opening up to the x. So 0, negative 5. So that means it would be right here. And that is going to be letter B, right, with that 0, negative 5 value. So the answers are C, A, B. Okay, and then it says identify the restrictions on the domain of the original function that ensures that the inverse is also a function. Then determine the equation of the inverse function and graph the inverse. Wow, that is a lot of stuff to work with. So what ends up happening is if I look at this specific function, I can actually tell whether it is going to have an inverse or not. The reason why is because if I end up doing something called the horizontal line test. If I do a horizontal line test, it ends up giving me 2 points that intersect the actual graph. If I have more than one point that's being intersected, it is not considered to be what we call one-to-one. One-to-one means that the graph has an inverse that is also a function. But in this case, this does not have an inverse. So what I'm going to do here is I'm going to decide on restricting the domain so that I can say that this will now become one-to-one, or the inverse is actually going to have a is actually going to be a function. So the idea is that this graph is in a sense like a cup, right? That it's a parabola. So if I remove both ends of the cup, or if I remove one end of the cup and really just focus to one side of it, then I can say from here to, let's say, here, I'll do that as a highlighter. So from here to here, and I only focus on that specific section starting at 2, then I can say that that will end up becoming one-to-one. It'll pass the horizontal line test. So what I'm going to do is I'm going to restrict the domain from 2 to infinity. Now, you have an option of restricting the domain in the opposite direction. So you could technically restrict the domain in negative infinity to 2, but then that will end up giving us another version of the equation that we want to work with. So we're just going to work with the more positive version because it is technically going to infinity for both the x and the y. Okay, so I'm going to write down my equation. Y is equal to, parentheses, x minus 2 to the second power. Now, I'm also writing this f of x as the value for y. So when I find the inverse, I switch the x and the y values. So I'm going to write x equals, parentheses, y minus 2 to the second. Then I'm going to solve for my y variable. So I'm going to start off by doing a square root. But when I do a square root to both sides, I need to remember that there is a plus and minus version. So plus and minus version. So I end up getting plus or minus square root of x is equal to y minus 2. Then I'm going to, in a sense, remove the minus 2 by adding 2. So I get plus or minus square root of x plus 2 is equal to y. Now, there are multiple versions of writing this. You can also write it as y equals 2 plus or minus square root of x. That's how most books like to write it. It still means the same exact thing if the square root of x is still going to be either positive or negative. But what ends up happening is if you were to actually graph this, right, this equation would actually look something like this. We would have a 2 here, and then we would start actually having that square root function heading out in this direction, and it would actually also head out in this direction, which means that this equation, since it has both the parts, the positive and the negative, right, makes it not a function. Although we did determine that earlier, that this is not going to actually be a function. So what I'm going to do here is, since the domain was restricted, right, the range, even though technically they didn't ask me to find it, this was from 0 to infinity. Now, when you're dealing with inverses, right, this is technically my inverse function, right? So I'm going to say 2 plus or minus square root of x. That means that the domain and the range also switch. So that means that the range goes from, in a sense, the range is 0 to infinity, so that means that the domain is going to go from 0 to infinity. And actually, doesn't that make sense, right? The lowest x value is going to be 0, goes all the way to infinity. But the range here is, instead of originally being all real numbers, right? This would be originally all real numbers in the context of this problem, right? Because it's going down to negative infinity and up to positive infinity. It's not going to be all real numbers anymore. And so we're going to say that that's going to go from 2 to infinity. So that means that this equation right here is actually going to change. And by changing this, I'm actually just going to remove the negative version of that. If you wanted to remove the positive version, so it would be 2 minus square root of x, then we would restrict the domain from negative infinity to 2. But since we did 2 to infinity, we want the plus version of that square root of x. Okay, so that leaves me at the end of my unit 2, so my second, in a sense, formative in my line of videos. Thank you again for watching, and I'll see you again next time.